Thank you very much for joining this webinar. Today, we are going to discuss the Wi-Fi optimization for the Modena wireless presentation system. And this webinar will last around 30-40 minutes. And we will start with some slides. And then we're going to have a live section where we have an evaluation about our meeting room, the Wi-Fi that we have, bandwidth of the network, so all the important key values to evaluate if a meeting room can work with the Modena system. But let's start with the introduction. My name is Mauro Barbieri. I'm field sales engineer at Biamp, and with me, my colleague Giulio.
Hello, everybody. And my name is Giulio Ferrari, and I'm technical support specialist at Biamp, also from Modena. So, speaking from the Italian offices of Biamp.
And the agenda for today is network integration. So we're going very fast, briefly looking at the way that we have to connect the Modena system to your network and offering the services to the customers, guests in general, and the company people. Wireless requirement. So we are going to describe what kind of network values we need to be able to have a very good Modena session. Then there's a live part of this webinar that is about the Wi-Fi measurement of the Wi-Fi values, the strength of the signal, signal-to-noise ratio, and the bandwidth. A part with the Modena Wi-Fi configuration. So you know that the Modena Hub Plus has an internal access point. So we're going to look at how we can configure the Modena Wi-Fi internal access point for providing the best possible connection. Few words about the requirement for user devices. That is the other relevant ring in the chain. So on one side, we need a good transport, a good network. On the other side, we need a good CPU in order to encode the content. And so we are going to describe what kind of devices we need and where to find the information. At the end, we have enough time for a Q&A session. But let's start immediately with the network integration. So in this slide, we have the classic integration, the classic connection for the Modena Hub. So the way that we use mainly to connect to the network. As you can see, we can connect the Ethernet interface of the Modena Hub to the company network. So this connection is what we usually call enterprise network integration. In this way, we use the company infrastructure for providing the connection to the Modena system and for delivering the services of Modena Hub, mainly wireless presentation and then the wireless BYOM. So the way that we use to have, for example, a Teams call without connecting any cable. So company people, guests, connect to the company infrastructure. As you can see, we then connect the display of the meeting room to the Modena Hub, and through using a USB hub, we also connect the camera and the audio section, in this case at the Zero Forte with parlay microphone and sound speaker. In case we have the Modena Hub Plus, we can also use the integrated access point, and the advantage of having this integrated access point is to provide a very easy connection for the guest. Without the integrated access point, so using Modena Hub, the guests in the company need to connect to the guest network of the company. So they need to have an account for the guest network of the company, and the IT department need to configure the network to make Modena Hub visible to both the two VLAN, so the company and guest network. Using Modena Hub, the configuration of the network is very easy because the guest can connect directly to the integrated access point. You can publish on the display and so on the welcome screen the SSID and the password, so the guest easily can get into the meeting room, connect to the SSID, and start sending the presentation, for example. So very, very easy in terms of network configuration and very nice user experience. In this case, for the company people, Modena Hub Plus is also connected to the enterprise network, so the company infrastructure for the company people. And exactly as in the previous design, we have the display connected and the USB hub with camera and audio section, the audio equipment of the meeting room. Then on Cornerstone, the Biamp technical website where you can find all the technical information, design guides, and network guides. You can also find some documents about the network requirement. In this case, just as an example, we have the list of required ports that we use for providing the Modena services. So the port for the transport of the video stream, the audio stream, port for the discovery, or the ports that we use for talking with the external world, for the DNS, for example, the weather widget, and so on. So generally speaking, you can go on the Cornerstone website, the Biamp technical website, for looking and finding all the technical information related to the network configuration very, very easily. And talking about real-time streaming, you know that wireless presentation means sending video content to the display of the meeting room in real time. So we send the content and we want to watch the content on the main display of the meeting room without any latency. So this is the one of the requirements, low latency, high bandwidth, because we are transferring a lot of data. It's video content, so a lot of data. And of course, we need stability and reliability because we do not want an interruption during our presentation session or during our wireless meetings. So in few words, this means that real-time streaming, during real-time streaming, we can't buffer because it's real-time. There's no possibility to have any buffer during the video transmission. We can't have retransmit because, again, it's real-time streaming. So we can't afford any error during the transmission, and we can afford packet loss. Otherwise, we lose frames, and so we have interruption during the wireless presentation. So just to recap, we need a very good network with low latency, good quality, good bandwidth, and a stable network. And since Modena Hub is a wireless presentation system and use the Wi-Fi, it means that we need a very good Wi-Fi, reliable and allowing high bandwidth and low latency. But what does it mean to have a good Wi-Fi? We're trying to explain what a good Wi-Fi is. First of all, Wi-Fi is a family of different standards evolving during the time, starting with the Wi-Fi 1 or the 802.11b, the first one, and up to the current standard that is Wi-Fi 6. And the Wi-Fi started as an half duplex technology. So the device connected to the access point first send data, then receive data, and then is the turn of the next device connected to the access point. This was the beginning of the Wi-Fi. It means that there's a polling cycle in the connected devices, and the process is quite slow with very, very small bandwidth. Then at a certain point, the MIMO technology was introduced. MIMO technology means multiple input, multiple output. Using more antennas and more streams, it's possible for a single device to send and receive data at the same time. And the MIMO technology allowed to have this MIMO on multiple users. So in this way, we are able to have a kind of full duplex on multiple devices at the same time. And this starts to be available from Wi-Fi 5 wave second. This is the reason why we suggest to use Wi-Fi 5 access points, Wi-Fi 5 with MU-MIMO, and Wi-Fi 5 devices. And our suggestion is not to mix old and new technology, because when you have new devices and old devices, the whole group of devices and in general the performances of the Wi-Fi network can be affected by the old standards. So our suggestion is to use the Wi-Fi 5. Also, would be very nice to have the Wi-Fi 6, but even if it starts to be available in the middle of 2019, I have to say that is not really available everywhere. So not every new device has the Wi-Fi 6 card, and not all the access points that you can find in the company is already Wi-Fi 6. So everything on Modena hub was tuned around Wi-Fi 5. Last information about the standards of the Wi-Fi. With the Wi-Fi, we have mainly two bands. With the Wi-Fi 6, we have an additional band, but mainly we have 2.4 and 5 gigahertz. And in the same band, we can have more channels. So a single band of 5 gigahertz is divided into a small section called channels. And this strategy of using more channels allow to use more devices, more access points without interference. So in this way, we can have more connection and more devices in the same band. And the analogy is with the roads and lanes. Having more lanes in a single road means that we can have more traffic without staying in the queue in a single lane. So it's far better to avoid congestion, to avoid interference between different devices and access points, and to increase the bandwidth. Last information about channels is that on the access points, it's possible to configure what is called channel bonding. So using more than one channel together as a double lane, for example, or a lane with a double size. In this way, we can obtain higher bandwidth, so better speed for the traffic. Then Wi-Fi key values. So how we can evaluate if a Wi-Fi is good enough for a Modena session. We can evaluate the signal strength, so the amount of Wi-Fi signal we receive on our user device. Then the signal to noise ratio, so the difference between the value of the signal and the noise floor. You know that on the Wi-Fi, we have a noise floor, so some noise that we have in the spectrum created by devices, electrical devices in general, so can be engines, microwave ovens, but mainly Wi-Fi cards. So the noise is created by the devices with the Wi-Fi cards, Bluetooth cards, and so we have this kind of noise floor. And the most important value is the difference between the signal strength and the noise floor. That difference tells us exactly the quality of the signal that we have. Exactly the same situation that we have with signal and noise in the audio. Last one is the bandwidth. Bandwidth is the amount of data that we can exchange from a device to another in a period of time. And let's say a real evaluation of the bandwidth tell us the quality of the network that we have. So it's very important parameter to evaluate the real quality and the stability of our network. So starting with the signal strength. Signal strength is the amount of radio signal we achieve from the access point on our user device, and is measured between 0 and minus 100 decibel by milliwatt, so is measured in attenuation. And a level of -70 is generally good enough for office application, for web browsing, emails, not for real-time streaming. For real-time streaming, especially using Modena, the minimum that we need to achieve is -65. This is the minimum requirement. Below -65, the quality of the Wi-Fi is not enough for real-time streaming. Our suggestion is to have at least -60 in order to have some headroom and to have a better connection. Of course, if you have a better quality, let's say -50, for example, in this case, the quality of the Wi-Fi will be very good with good speed and good reliability. Then talking about signal-to-noise ratio is the difference between the signal, as we saw before, and the noise floor. Usually, the noise floor is in the range of -90 and -100. And for measuring the noise, we need a professional tool. And but most of the time in office environment, we can estimate the noise floor around -95. So if you have a professional tool and you can measure the noise, you can have the real value. Otherwise, if you can't measure the real value, you can estimate -95. And the difference between the noise and the signal strength tells you the signal-to-noise ratio. As we can see in this table, if you have a signal-to-noise ratio around 20 dB or less, it's good for office application, not for real-time streaming. For a modern application, you require at least 25 dB of signal-to-noise ratio. Better to have, our suggestion is to try to configure your network in order to have at least 35 dB for signal-to-noise ratio, for having a very good quality in your modern session. Of course, again, if you have 40 and above, you have a very, very good, excellent connection. The last one, before starting with the live experience, is the bandwidth. The closest analogy with the bandwidth is the internet speed test. Every time that we want to double check the quality of our connection with internet, we start an internet speed test. And this is measuring the bandwidth, so the amount of data that we can exchange in a period of time, or in other words, the speed of our connection between our user device and a server on the internet. And this is the bandwidth that we are usually checking for internet speed. In the case of Modena, the process is exactly the same. We need to measure the bandwidth, but in a different segment that is between our user device and the Modena device. So in other words, we have 2 points. We start exchanging data and measuring the speed. And so we are measuring the relevant segment that is between our device and the access point, then access point, cable switch, and so on, up to the Modena hub connection. This is the segment that we are going to measure to evaluate the quality of our connection. And talking about the requirement for the bandwidth, Modena is using traffic in 2 ways. So usually we present data from our laptop or our user device to the display of the room. So we are sending data up, but also we can connect, every participant can connect a user device and receive the presentation. So in that case, we have traffic down. And also we can use Modena for a wireless meeting, so a wireless BYOM. In that case, the host of the Teams call, for example, received the data from the camera. In that case, traffic down again. And every stream, for every stream, the average required by Modena is 4 megabits. So we need an average of 4 megabits for every presenter, an average of 4 megabits down for every receiver, and another stream 4 megabits average for receiving the camera. And And this is the average. And of course, when we receive keyframes or when we start the connection, we can have some peaks up to 15 megabits. This is very important value to evaluate the bandwidth that we need, because as you can understand, if we have only one presenter, so it's very simple, and the requirement for the bandwidth is very, very low. But if we have more presenters and also more receivers, we need a bigger bandwidth. But now let's start with the practical evaluation. So I leave Giulio going ahead and.
Yeah, thank you, Mauro. Yes, we just saw a few concepts about the Wi-Fi, how the Wi-Fi is divided into different families with different technologies, and the working of different bands and channels. And most important, we've seen that there are 3 parameters that we have to check and configure to make the best out of our Wi-Fi network. And in this live part, we will see how we can check the values of these parameters to make sure that they're good for our Modena connection and in general for a good Wi-Fi connection. The first tool that we are going to use is Acrylic. This is just one of the software, the programs that you can use to check for Wi-Fi networks. We chose this because it has a good interface, it's simple to read. There's also, we are using the professional version, there's also a trial version that lasts for a week, so you can try, and it's cheap software anyway. So good, we think it's a good tool for the scanning the network. There are others that you can try. The main idea of using Acrylic is that with this software we can check the RSSI, which is, as we saw, the signal strength, the power of the Wi-Fi connection that we want to use. And when you launch Acrylic, you see on the top part of the program a list of all the SSIDs that are available from where we are now. So from the Wi-Fi module of our laptop, we can see all these networks. So the first column is the name of the access point that is available from here. There is one row which is highlighted, and it's the Biamp Italy. In our case, is the Wi-Fi access point that we are connected to in this very moment. And very interesting to see is the third column here, the RSSI, which is the value that we want to check. And you can see in this case, the network that we are connected to right now, it's -47, so very good. We've seen that above -50 is very good connection, so we are using a good Wi-Fi right now. It's interesting to click on this column because it will allow us to order all the access points that are available from the best to the worst. And we can check all the available networks here. And here you can notice in light blue, there's also the Modena. This is the other Wi-Fi access point that we mentioned, the one created by the onboard Wi-Fi module of the Modena. It's currently, the signal strength is currently -43, good connection. And then the next column, very interesting, is the channel. You can see in blue, we have channels that are on the 2.4 gigahertz, and on the dark red, we have the 5 gigahertz bandwidth. And also clicking on the channel here, we can order the channel and check that the networks are working on different channels. Why is this interesting? We are introducing a concept of what we can call a channel strategy. We saw that we have different bands and different channels, and it's key to set up a Wi-Fi system in a way that access points that are close, in maybe rooms that are close one to the other, they are working on different channels, so they don't interfere one with the other. So this is an important information to be able to set up our Wi-Fi system, and specifically the Modena in our case, so it doesn't interfere or receive interference from other channels. When there's a single channel here, it means that it's working with a 20 megahertz bandwidth, so single channel. But you can also see in the network that you use now, for example, 108 plus 116, or the Modena is 44 plus 48. It means that it's using more channels at the same time. It's what we call the channel bonding, as explained before. It means that we have a larger road, larger band for our connection, and it's also useful for this channel strategy as mentioned. And then we have details about the type of Wi-Fi that is in use and the maximum bandwidth that is available on a specific access point. And this depends on the Wi-Fi generation, the technology that it's used, the number of antennas. So this is another useful information. And you see that on the 5 gigahertz, the maximum bandwidth is much larger than the 2.4 networks. On the bottom part, we have it's the signal strength is shown with a graph. We can check the network quality, so we are giving just a summary of the situation. We have we can check in the 2.4 gigahertz tab all the available access points on this band, and on the 5 gigahertz the same. So we can see in I can click the Biamp Italy network that we are using now. We can see that it's a very good connection, very good power signal strength, and we can also check that it's not interfering with other access points on the very same channel. So this is on one side, it's a measurement of the RSSI value and a way to check the channels that are being used by all the access points that we have here. The second parameters that we mentioned was the signal to noise ratio, and this is not really something that we can measure with a Windows laptop. We need professional tool to do that, but we also mentioned that it's something that we can estimate in a normal office environment to be between -90 and -95. It means that now with the RSSI that we are connected to is -46, and we subtract -95, we are close to 50 dB signal to noise ratio, which is a very good ratio that we can definitely use for our connection. So speaking of channel strategy, once we've done this, so we have a look at the situation of all the access points that are available here. We can go to the Modena and check the values of our access point on board the Modena. So I open the browser, and we are already connected to the IP of the Modena. It's the IP that I can see on the welcome screen of the unit. And I will enter the admin, typing my password. And we are inside the web administration of the Modena. Now we are going to skip all the configuration which is not in the scope of today's presentation, going straight to the network, where we can find two tabs. One is for the wired connection and one for the Wi-Fi, the wireless module. On the wired, we have typical DHCP or static IP. I can configure the wired network from here, but what we want to check is the parameters of our access point on board the Modena. So we have the SSID and password. We can change that. We can decide if we want to show the SSID password in the status bar and in the TV welcome screen, so it's easy for guests to connect to the Modena right away. We can select a share mode. It means that we can reach the Modena completely as a part of the enterprise network, just another access point in the network, or we can select the routing plus NAT, which is the default value, up to none. When we select none, we have two completely separated networks. The wired network and the wireless network of Modena are completely separate. But of course, users, enterprise user and guest users can connect to the same Modena session to use that for presentation and receive the presentation. Then we have our IP. We can set the country. We can check, we can change the frequency and select the 2.4 or the 5 gigahertz of the Modena access point, the AC that is available with the Wi-Fi 5. And here is where we can really change and optimize the channel strategy, as we just mentioned. So from here, I can select a channel that I've checked on the scanner software, Acrylic in our case, to be free. And I can also decide the channel width. That can be a single channel or double or 4 times the channel. So in our case, we're using width of 40 megahertz, which is 2 channels. I can select the transmit power, which is now on high, and I can change the configuration of the DHCP server. So this is a rather standard configuration. But from here, very important, the part where we can really select a free channel and configure our system to be able to work without interferences from other Wi-Fi devices. Then before we leave these pages, we go to the advanced, and I want to show you that under the network, there is an option Hyper-3 server. And this is what we will use for the third parameters, the bandwidth that we want to check. We will use a software called iPerf, which comes in a client-server configuration. So we already have the server part on board the Modena. We already downloaded the free client for Windows. It's a very simple client that works with a command line interface, really simple. So we just downloaded the client from the iPerf website, and we can check the bandwidth from here. So we made sure that the iPerf server is up and running on the Modena. It's already installed, and we saw that it's running. So we can now launch the test and check the actual bandwidth. Again, now we are checking bandwidth that is really from our laptop here up to the Modena. So going to the access point that we are using now, the cables, the switches up to the Modena, which is connected to the enterprise network. To use the iPerf, I just type my command, which is iPerf3 -C. I'm using the iPerf in a client mode. Then I need to put the IP address of the Modena. Again, is the IP that I can see on the welcome screen. So it's 10.32.12.32. Then I need to select the port, so -P, and port for Modena is always 6998. And option, I can also select a time in seconds. I want to check the bandwidth for 30 seconds in my case. So I just launch the program, and it's measuring the bandwidth in real time. So we are now between 65 and 75. For 30 seconds, we'll keep polling and pinging the Modena, the iPerf server that is on board the Modena, and checking the bandwidth. So we have good bandwidth, good for Modena use and for presentation. And so it's important to check not only the value of the bandwidth, but the fact that the value is stable. If we have a very high bandwidth, but then it drops to nearly 0 for any reason, it means that our connection won't be really stable, and we have the risk of losing connection with the Modena for any reason. Launching again the same command with an R at the end of the command, I'm doing a reverse check. So I was sending data from my laptop to the Modena. Now I'm doing vice versa. I'm receiving data from the Modena. And again, we can check it's going a bit up and down, but it's always good and rather stable connection. So it means that definitely we have a good situation here with the Modena, as we expected from all the checks that we did until now. So we checked the three parameters: the RSSI, the signal to noise ratio, and the bandwidth. Now, one last part, which is again very important, is the device requirements. We've been talking and discussing the Wi-Fi, but another part which is as important is having a good hardware, so good Windows or Mac OS laptop or a good mobile device. This is because the Modena is doing an intensive computing process in encoding the video stream in real time and sending it to the Modena unit. So this needs to be done on the device that you're using for the presentation. Here there are a few values. There's no need to learn this by heart. Everything is available on Cornerstone. We have all the details there. So this is just to give you an idea that it's something that needs to be considered. With computers that are older than 3-4 years, there's the risk that the connection might be not as stable as we want it to be. A very good indication is also a look at the CPU. When the CPU, when Modena is running and presenting, is above 70 or 75%, it means that we are again risking a possible disconnection or a slowdown in the presentation, which is something we don't want. So please check Cornerstone, the technical knowledge base of Biamp, available on our website, to learn about all these hardware requirements. We are towards the end of the presentation, and we want to remind you that we have a training available for Modena called Collaborate Without Constraints. Next date will be April the 7th, and more information is available on Biamp website, again in the training section. So this will give you a full training on the Modena system and a certification, Biamp certification at the end. So it's complete training regarding the Modena if you want to learn more about this system. We are at the end, so let's check if we have questions in the chat. There's plenty of time, so please do send any questions that you may have, and we will answer them in real time.
Apparently, in this moment, we don't have any question, but yeah, if
just give it a couple of minutes, and
yeah,
if we have no questions, then
if there's something that you want to ask, please feel free. Just as a recap, just to evaluate if our meeting room is able to drive a very successful Modena session, you need to have enough Wi-Fi value. So the Wi-Fi, the radio strength should be above -60 dB, and you can easily measure using acrylic. Then the signal to noise ratio, if you can measure with a professional tool, we are not talking about expensive tool, just an external antenna is sometimes enough to measure the noise, or sometimes if you have a MacBook, in the MacBook, the measurement of the noise value is embedded. Unfortunately, not available in the standard Windows. In case you can't measure the Wi-Fi noise, you can estimate -95. So with a Wi-Fi analyzer like acrylic and estimating -95 as a noise, you can have an idea about the signal to noise ratio that you have. All the requirements, of course, are on Cornerstone, so you don't need to memorize the tables that we saw, but generally speaking, we need at least 25 dB as a signal to noise ratio. The last value is about the bandwidth. Modena, just for sending the video to the display, require an average of 4 megabits. So this is the requirement for one single stream. If you have two presenters, of course, we have an average of 8. If together maybe we have 3 people receiving the presentation, it's 3 by 4 on the opposite direction, so down. And it's very easy to work out the general bandwidth that you need in a meeting room. Take into consideration that when you connect a laptop to the access point for a Modena session, that laptop is creating traffic up and down, but also for the Modena application, but also maybe you have some other application running using the network, an update of Windows, a download of emails, attachment, for example, synchronization of a cloud storage, just to mention some examples. So this means that when you work out the bandwidth, you need to have some headroom, and usually the information comes from the IT department or the IT expert of the company, who knows exactly what kind of application and the average bandwidth already in use. So this is the way to estimate the bandwidth that you need, and to measure the bandwidth, very easy. iPerf is an open source free software that is very, very commonly used.
Again, everything that we discussed today is available on a page about Wi-Fi on Cornerstone. So all the parameters, the target values, the software, links to the software that we use today, acrylic and iPerf, the iPerf command line, everything is available there. So there's a dedicated page on Cornerstone about Modena Wi-Fi. Please have a look, so there's no need to remember the values if you don't, and you will find everything there. So please let us know if you have any question. Contact support@biamp.com, and we'll be happy to answer all your doubts and questions.
So thank you, everybody. I don't see any question, and so I wish you a pleasant day, and see you soon on the next webinar about the Biamp solutions. So thank you and goodbye.
Thank you, everybody. Goodbye.